Hello my dear students, today we are going to study division restoring method in the subject Computer Organization and Architecture. My name is Himanshi Chaudhary from Department Computer Science and Engineering, Kite Group of Institutions. Let's start. To learn this topic, we must know that what is the shifting of bits, either left or right. So let's see one example. This is one bit, that is 0110. Now if it has to be left shift, then this 0 will come here, this 1 will come here, this 1 will come here, and 0 will be here. Now here we need to decide that what will be placed there, either 0 or 1. Okay, now what about this 0? Whenever we are shifting left, but in the left, if it is 4-bit register, this 0 will be lost. The 0 transferred here will be lost and the value will be 110, and here we need to decide that what will be the value, either 0 or 1. Next prerequisites is addition. We must know that how to add binary digits, and this you must have learned under the topic half adder. Next prerequisite is subtraction. This is something where we subtract binary digits, either 00, 01, 10 and 11, and this you must have learned in the topic half subtractor. Next we are doing 2's complement. 2's complement is nothing if a is some digital value, then if we will do a bar plus 1, it means complement of a, and adding 1 to it, this will give the result of 2's complement of any binary digit, that is 01, 10, anything. Okay, so these are some of the prerequisites that you must know before going through this topic. So what is the topic? Our topic is to divide the unsigned binary integers. What are unsigned binary integers? These are positive binary integers. So the numbers we will learn to divide here will be the positive numbers, and that they will be converted into binary integers, and then we will learn that how to divide these integer values. So let's learn first of all the paper pencil method. What is paper pencil method? In smaller classes you may have learned the method which is like this. Let's take one example. When we need to divide 10 by 4, your quotient will be 2 and the remainder is 2. How you evaluated is it? Now we need to draw something like this, and we will write the dividend here. What is dividend? This value 10. And next we will write divisor over here. What is divisor? Divisor is the denominator of this, that is 4. Then quotient will come here, and the remainder will be something that will remain here. Let's see this example, 10 divided by 4. So 10 is dividend, it will be written over here. Then we need to write divisor. Divisor will come here. Then we need to check that what value lesser than 10 comes in the table of 4. So if you know the table of 4, you'll know that 4 into 2 is 8, that is nearest lesser than 10. So what we will do, we will write 2 over here, that will be quotient, and 4 into 2 is 8, 8 will be written here, and 8 will be subtracted by the value 10, and the resultant will be written here, that value is 10, and this is the remainder what is left over. Now this value must be 0 when you need to end, when you want to end this, or lesser than 4. It means the value 2 is less than 4. So we cannot go further. There are methods, but we need to learn only this much, unsigned binary integers. So this was the paper pencil method. Now we need to learn our topic. The division of unsigned binary integers is instructive method. Instructive method means there are predefined instructions to do this division of unsigned binary integers. There are two methods which we will learn. First is restore method and second is non-restore method. Restore method is in bold because we will learn this in this video. Now these are the two methods which we will learn to divide any unsigned binary integers. And in restore method, we will be using a flowchart. It means there will be some instructions that we need to follow, and by using these instructions we will solve any division. So let's first of all learn the restore method with the help of flowchart. So let's see the flowchart for unsigned binary division. Now this is the flowchart for unsigned binary division. It means that these are the instructions through which we can solve any numerical to divide. Now here we are having start, then initialization, then some of the instructions. I am coloring these all so that you can understand it better when we solve any question for this. So let's see first example for this. Now we will learn one example of division by restore method. We are taking the example 11 divided by 3, where 11 is dividend, 3 is divisor, and 3 will be question because you know this simple division. So 3 will be the question and 2 will be the remainder. Now we are learning this process with very smaller value, but this process can divide the values of higher integers. And you are learning this method because you are in computer engineer and you must know that how our computer system is dividing, multiplying, adding the binary digits. So let's learn the restore method of unsigned binary integers. So this is the given flowchart. These are the instructions which we need to follow to solve the division of unsigned binary integers. Now let's start. First of all, we will initialize it with this, that we will write the number of bits. In M register, we will place the divisor. What is divisor? Divisor is 3. Now you must know that how to convert this numerical value to binary value. We will place zeros to A register. We will place the value of binary dividend to Q register. So C. This is the number of bits 4. In M we are placing divisor. What is divisor? Divisor is 3. So the binary value of 3 is placed here. Now notice this, that here we are placing 5-digit number. Why 5-digit? Whatever the value of n is here, we will write n plus 1 bits over here in M register. Okay. Next in A we need to place 0. So if this n is whatever, if it is 4, if the value of n is 4, then we will place the n plus 1 bits over here. Next in Q register we need to place the dividend. Dividend is 11, so the binary values for 11 is written over here. Now this dividend will decide the value of n, and whatever the size of n is here, n plus 1 size of these register M and A will be written over here. Now this method is initialize method. Now see, for your help I have color coded this. If this is of this color, the matching row will be of same color. I have zoomed this portion so that your visibility increases for this. Now we have initialized our table. You have seen in that previous slide. Next what we need to do, we have to shift left AQ. So what is AQ? AQ. You have to write this in the same order, otherwise it will be a problem to do this question. So please follow the same order if you are solving any question. Now we need to shift left AQ. So AQ is this value, we will shift left it. So this first bit of A will be here and it will be omitted because the size of register is fixed. So whatever value, the first value will come out, it will be omitted. This O is here, this O is here on the second bit, and this fourth 0 is here at third bit, and this fifth 0 is at fourth bit of next. This 1 will come here, then next 0 will be here, 1 is here and 1 is here. Now we need to decide that what we must write on the last bit. It is empty right now. before it is saying that do a is equal to a minus m. So we need to subtract m from a. Okay, we will not subtract it. What we will do, we will evaluate the value of minus m, then we will do a plus minus m. So let me show you. See, I have written the value of m, that is 00011. You can see here the value of m is 00011. Now to evaluate the minus m, we need to do the 2's complement of m. And what is the formula to evaluate the 2's complement? It is a bar plus 1. Here it will be m bar plus 1. So first of all we will evaluate the complement of m, that is m bar. So what is m bar? All ones will be converted to 0 and all zeros will be converted to ones. So this will be the value of m bar. Then later on we need to add 1, and after the addition of 1 to 11100, it will be 11101. Now we can say that minus m is this, and here I am showing you that we need to perform a minus m. We will not do this. What we will do? We will do a plus of minus m, and we have evaluated the value of minus m. From here we are having the value of a. We need to add 4 times 01 to 11101. So I am saving the value of minus m over here because we need to use this. So let's add a with minus m. So the value of a is 000, 4 times 0 1, and minus m is 11101. So let's add this. What is the value of 1 plus 1? 1 plus 1 is 2, and 2's binary value is 10. So 0 will be written over here and 1 will be written here. 1 plus 0 is 1 and 1 plus 0 is 1. So answer here will be 1. Now here 0 plus 1 is 1. Similarly 0 plus 1 is 1, and similarly 0 plus 1 is 1. So we have got the values of a is equal to a minus m, that we need to write here. See, a is equal to a minus 1 is done. The answer is 4 times 1, 0. So updated value of a is written over here. This is same as previous and this is same as previous. Now next instruction is saying that check the MSB of a. So let's check. MSB of a is 1. So if the MSB of a is 1, we need to do this step. At the place Q0, we need to place 0. It means it's saying that on this position place 0 and restore a. What is restore a? Restore a means that omit this value and use the previous value, that is 4 times 0, 1. So let's see this. Next step is saying that place 0 at the position Q0. So we have written this and restore the value a. It means this value will come here. Okay. Now because we are doing restore a over here, this algorithm is termed as division by restoring method. Next we can see that it is n is equal to n minus 1. What is n? N was 4. We need to subtract 1 from 4. So here we need to write 3. So third step is written over here. Next we will check if n is equal to 0. So is my value of n is 0? No, it is 3. So it is false. So we will go back and start this algorithm again. Again we need to shift left AQ. So this is the value of AQ. You have to shift left. Now see, I have already done this. This is the value of AQ and this has been shift left. Again on the last bit, we do not know that what to place. Now in the next step, we need to perform this a is equal to a minus m. This is the value of a and this is the value of minus m. So we will add these values. So this will be 00010, the value of a, and we will add this. It will be 11101. So 1 plus 0 is 1, 1 plus 0 is 1, 1 plus 0 1, 1 plus 0 1, and 1 plus 0 1. So the answer is 5 times 1. So I have written the answer 5 times 1, that is the updated value of A over here. This M is same, this Q is same. Now next we need to check that what is the MSB of A. So this is the value of A and MSB is 1. If it is 1, we will perform this step again. So at the place Q0, it means this position, we will place 0 and restore the value of A. Restore the value of A means that this 00010 will be written over here. So at the place of Q0, we wrote 0 and restored A. 00010 is written over here. Next we will subtract the value of n. This 3 will become 2 and we will go back and then we will shift left AQ. It means this is the value of AQ and it will be shift left by 1 digit. Okay, so let's see. So the value of n is subtracted and these both values are shift left. Okay, hope you understand that how these are shift left. This 0 is omitted, 0010 is written over here, this 1 will come here, this 1 is here and this 00 are here, and on the last bit we do not know what to place right now. Next we will again do A is equal to A minus M. We are having the value of A, we are having the value of minus M, we will add this. A is 00101, 00101 and M is 11101. So 1 plus 1 is 2 and 2 is written like 10. 1 plus 0 is 1, 1 plus 0 is 1, 1 is written over here. 1 plus 1 is 2, 2 is written like 10. So 1 plus 0 is 1, 1 plus 1 is 2, 2 is written like 10, so 0 will be here, 1 will be here. 1 plus 0 is 1, 1 plus 1 is 2, so 2 is written like 0, and because we cannot write carry above, so carry will be here. But because this is only a 5-bit register, only these value will be considered and this one will be omitted. So see, the updated value is 0, the evaluated value is written over here, and else everything is same. Now next we need to check what is the MSB of A. So this is the value of A, MSB is 0, it means we will move here. Here we can see that at the position Q0 we need to place 1. It means at this position 1 will be placed. So we have written 1 over here and the new value for Q is 1001. Next we will go further. The value of n is subtracted by 1. That will be done here. It means that 2 is converted to 1. Next, obviously 1 is not equal to 0. We will go back and shift left AQ. The value of AQ is given here. You have to shift left it. So let's see the result. 1, because we subtracted, n is equal to n minus 1. M is same. AQ is shift lefted. So this 0 is here, 0 is here. This 1 is here, 0 is here. This 1 is here, this 0 is here, 0 is here, 1 is here, and now we do not know what to place here. But in the next step we need to do again A is equal to A minus 1. So we are having the value of A, we are having the value of minus M, we will add this. A is 00101 and M is 11101. So let's add this. 1 plus 1 is 2, that is 10. 1 plus 0 is 1, 1 plus 0 is 1, so 1 will be placed here. 1 plus 1 is 2, so 0 will place here and carry will be written here. 1 plus 0 is 1, 1 plus 1 is 2, 0 will be written here, 1 will be written here. 1 plus 0 is 1, 1 plus 1 is 2, it will be 100010. Now because it is 5-bit register, we need to use only these 5 bits and this one will be omitted. So the next A value must be 00010. So let's see. So the updated value for A is 00010. You can match it here. Else everything is same. Next we will check the MSB of A. So MSB of A is 0. If it is 0, we need to move here. The value of Q0 will be 1. It means at this position we need to write 1. So we will do this. Q, on the last bit we wrote 1. And the A's values is 00010. Now next to this we have to subtract n again. The last value of n is 1. We will subtract one value from this one and it will become 0. It means on the next step we will check if n is equal to 0 and it's yes. If it is yes, we will move further. Now I have zoomed out this flowchart. Now we were here in the last slide. Now if n is equal to 0, it means after when this 1 is 0, then we will move to next step. That is, we will see that in Q register, it means on this register, the value it is having, that is 0011, will be the quotient. And in A register, we will have the value for remainder. It means this algorithm is complete. We have done all the steps of this flowchart and we are able to see that in the register A and Q, we are having results. In register A, we are having remainder, that is the value 2, and in Q register we are having the value of quotient. And you can see the value of quotient we discussed in starting is 3 and the resultant is 3. So it means these both are matching. Our algorithm is successful. And the remainder was 2. Here also the remainder is 2. So our flowchart is successful in finding the result for division by restore method. After that we have to stop it. Now you can note this example and solve another question. So now you can try yourself. These are the two questions that you can solve by using that flowchart. Try to solve this question and try to find that what is the quotient and remainder for the both divisions. Now for reference purpose, I have used two books, that is Morris Meno, Computer System and Architecture, and William Stalling, Computer Organization and Architecture. These both books are standard books which we can follow to learn computer system architecture. So thank you. Hope you have learned something new.